All right, problem number 5 gives us a polynomial function that is third degree, and the leading coefficient is positive, so it is down on the left, up on the right. And we have a small version, and it's actually an incomplete version of the graph. All it shows us is that there is an x-intercept, therefore a 0 at -4. So I'm going to scroll down to where I have some room to write. This is my function, and this is the one given 0. My instructions are to find all of the zeros. Remember that because this is third degree, I should be able to find 3 zeros. I don't know whether that will show as 3 x-intercepts, but it will be 3 zeros, and I was given 1. So let's use synthetic division with the 0 that we have and try to depress this cubic or third degree function. Whoops. All I need to write in here is a 9, a 6, a -95, and 100. Draw a line, bring down the 9. 9 times -4 is -36. Add for -30. -30 times -4 is positive 120. When I do that addition, I actually subtract, keeping the sign of the large one, and I get positive 25. 25 times -4 is -100. That means I got a remainder of 0, and the picture, I read it correctly, the 0 was at -4. Now, rather than putting it in my grapher and searching more, I'm going to take this. Sorry about that interruption. All right, so I have depressed the third degree polynomial function using synthetic division with one of the zeros. I now have as the other factor 9x squared minus 30x plus 25. And if I want to find the remaining zeros, I can set this equal to 0, and I might be able to factor it. Well, as a matter of fact, looking at it, I believe it's actually a perfect square trinomial. So let's see if these are both minus. Put in the x. To get 9, I could use 1 and 9, or I could do 3 and 3. For 25, I could do 1 and 25, or I could do 5 and 5. I'm going to use 3x and 3x, and I'm going to use a 5 and a 5. That gives me an outer product of -15x and an inner of -15x that adds up to be -30x. If I set 3x minus 5 equal to 0, that means 3x is 5, x is the fraction 5/3. This is a repeat, and I will get x is 5/3 again. I hope that it's jogging your memory. If this is a 0 or a root twice, then as a factor, it will be multiplicity 2. And in the graph, it should touch it there, not cross it there. So if I go back to the question, and it said to find all of the zeros, well, one of them is -4 that I could see right up here. The others that I couldn't see because I didn't put it in my grapher are both 5/3. So it will only want me to write it once, even though it represents 2 zeros. So what is this going to look like? Well, we had already said it's down on the left and up on the right. And third degree functions sometimes look kind of like this roller coaster. But this is the -4, and the 5/3, which is between 1 and 2, has to be a double, multiplicity 2. So it looks like it's this one, that is 5/3, which is 1 and 2/3. So my choice for the graph is A. Okay, I hope that helps with that question.